Okay, this is chapter 8, day 7, which I consider the key lesson. This kind of is toward the end here, where we're kind of reviewing, okay? So, the goal of a confidence interval is to give us a range of where the true mean or the true proportion lies. Because most of our statistics are means or proportions. Now, later you're going to see two sample means and two sample proportions. But right now, we're just dealing with a single mean and a single proportion. So you go out and you do a study, and the study has to be done correctly. You get that data, and then you can draw a conclusion on where you think the true mean or true proportion is for this scenario, okay? So we're gonna do one prompt that's a proportion, and we're going to do one prompt that's a mean. And the answer key is already written out for you, so I'll be writing very little. Okay, in order to determine how many Valentine's Day grams to produce, ASB took a poll of 47 students randomly and selected and asked them, are you likely to purchase grams this year? 13 of the students said yes. Okay, so what they're trying to do is figure out how many are we going to produce. We got 2,000 kids. What percentage of kids will buy them? We don't want to make too many grams and waste valuable resources and time, and we don't want to make too few either to cut off opportunity. So the assumptions are the conditions that what we're going to go with to assume that we have a good sample to draw a conclusion from is as follows. If you remember, our assumptions make the acronym SPIN, okay? And the S stands for a good sample, a sample that's representative. So we have a representative sample of LQ students. We're assuming that they got a good sample, not some strange skewed sample, okay? We're assuming the population is at least 10 times the sample size. So there's more than 470 students attending LQ. We know that's true because there's about 2,000 kids. This is also called the 10% rule, where you should not be sampling more than 10% of the population. And the reason for that is buried in the laws of replacement, which is too big of a topic for here, okay? The I in SPIN stands for independent. We're assuming everyone's response was independent. They weren't influenced by somebody standing next to them, etc. Okay? And we've got to make sure that we have a sufficiently large sample size so that we have a normal curve. Now, we're not going to see the actual curve in this particular lesson, but a confidence interval takes the middle 95% of a curve, or the middle 99% of the curve, or the middle 90% of the curve to do its calculation. So in order to have a normal curve, we have to make sure that we have a large enough sample, but not too large of a sample where we violate laws of replacement. So to do that, we're going to go N, that's the number in the sample, times the given percentage, and it's 0.277. I got this number simply by taking 13 and dividing it by 47. And that is bigger than 10, as you can see, which is greater than 10. And N times 1 minus P, which is simply 1 minus 0.277. That's also bigger than 10. So I have met the criteria to actually draw a proper conclusion from our confidence interval. All right. Now, if you remember the confidence interval, and I'm going to write this out, the basic confidence interval for a mean is going to be, or a proportion in this case, excuse me, is going to be P hat plus or minus Z star. Now, if you remember, Z star is the number at the bottom of the page on the table, which I'm not showing you here, okay? Times the square root of P, which is 0.277, P hat I should say, okay? 1 minus P, which is 0.723 over N, and N in this case is 47, okay? So this is P hat, This is 1 minus p hat. That's the basic schematic of it. And if you recall, in confidence intervals, there's going to be 4 of them for means and proportions. A single mean, a double mean, a single proportion, and a double proportion, coming later, okay? But it's always the same thing. Your statistic, which in this case is p hat, a sample proportion, plus or minus a critical value. That's going to be z star or t star. And in this case, it's multiplied by the standard deviation of that statistic, which in this case is p hat 1 minus p hat over n. Okay, so let me erase that, and then you can go ahead and check out, try that again. Okay, and then you can go ahead and check out how this works. So there's p hat, plus or minus. This is z star at 90% confident, 1.645. P hat 1 minus p hat over n. Now, I'm going to go over to the calculator and show you how to punch this in, okay? Because you can actually do this off of the calculator and not do it by hand. So let me go over to the calculator. Okay, so you're going to go stat and over to tests, stat tests. And you're going to go down a ways, and you're going to go 1 prop z interval. On my calculator, it's item A. And you're going to type in 13, the numerator of that proportion, and 47, okay? Type in 13 over 47, and then you're going to tell it what confidence level you wanted, which was 0.9. And then you're going to hit calculate. What that's going to do is it's going to eliminate making mistakes in calculations. So it's really nice to be able to do that, okay? And as you can see, that is the answer produced right here. So somewhere between 17% and 38% of the kids want to buy grams. That's still a pretty wide interval, and you're going to have to make some educated guesses or poll a little bit more to get a more accurate reading on how many you want to buy. But that gives you at least a start, okay? Okay, now, common questions on the AP test involve interpreting the meaning of the interval or interpreting the meaning of the confidence level. They're actually different questions. I have interpreting the meaning of the interval, and this is a sentence frame, okay? And so we are 90% confident that the true proportion of students who will purchase a gram is between about 17% and about 38%, because the process we use is effective 90% of the time. So this is your basic frame that you're going to use. Now, you might say true mean here if the problem's about a mean. Or you might say true difference between the two proportions if it's a two proportion situation. Or you might say the true difference between the two means. So there could be one of 4 things that's going to be put in there, depending on if you're doing a mean, a proportion, 1 sample, or 2. Okay? And then item D, I got to scroll up real quick. So item D is fairly common, is they want you to come up with how many samples would you need to be able to do something, okay? And so we know that the margin of error, this is called the margin of error, MOE, is the critical value, which is Z star, times P, 1 minus P, which is also called Q, over N. So we're going to have this part, and we want to be 90% confident, so 90% is right here, okay, 1.645. And we're going to stick with our P and our 1 minus P right there. And we're going to put N down there. And we're saying that this whole thing right here needs to equal 3%. 3% is 0.03. Then you have to do algebra to go ahead and solve this, okay? Which basically involves, You got to square both sides to get rid of this, etc. It involves a little bit of work. You're going to go 0.03 divided by 1.645. Then you're going to square it, and then you'll go ahead and finish it off. It takes a little bit of work to be able to do this, okay, on your calculator. So go ahead and try that and see if you can get about this answer, which rounds to about 603, okay? So that right there is a problem involving a confidence interval for a single proportion. Now we're going to do a confidence interval for a single mean, okay? For a single mean. So let me scroll that up. Okay, here's the confidence interval for a single mean. Again, I'm doing an ASB problem here. A random sample of 34 students who entered the ASB store found that each student spent an average of $4.50. Bought a soda, a couple snacks, and a standard deviation of 225, okay? Now, this is we're gonna try to get some information about how much kids spend on average, okay? And to do so, we need to meet certain conditions for our study. Was the study done correctly, etc.? And we're going to be making some assumptions on that. Assumptions are made all the time because you don't know if you actually have good data until after the fact often, but at least you want to try to have that. And that requirements are called SPIN. Okay, that's the acronym for the requirements, okay? So the S stands for representative sample. So I'm going to write, we have a representative sample of LQ students. We're assuming that. By the way, on any kind of paper or test, don't put the spin, don't put that. Just go ahead and put bullet points. This is just an acronym for you to remember. It's not to be written out. I have it on my notes to help you, okay? We're assuming the population is at least 340 at LQ. Again, the 10% rule. We did not sample more than 10% of the kids. We're assuming each amount is independent, no problem there. And the sample size is sufficiently large because 34 is greater than 30. 30 is the magic number for a mean, not a proportion, for a mean, to say, yeah, the central limit theorem is going to give us a normal curve. And remember, the confidence interval is going to take the middle part of that normal curve for its answer, okay? All right, now, we're going to go ahead, I'm going to move this up and we're going to look at the other questions. Okay, so item B, construct a 95% confidence interval for the average amount that students spend. Okay, now, if you remember, the basic formula is X bar, not P hat, because we're dealing with the mean, plus or minus T star. We're going to use the critical values of T, which involves that chart, finding the sample size and going n minus 1. I don't have the chart here, but hopefully you've seen that and you're able to navigate that. It's in your book, or you probably have an open sheet of that, okay? Times S divided by the square root of n. This could also be sigma if you're dealing with a known standard deviation, but most of the time it's S. Okay, so there is your X bar. The average that we have on hand is 4.5. This number, 2.042, 95% for a Z is 1.96, but that's at the bottom of the page. We have 34 samples, so our degrees of freedom is 33, but the chart doesn't have every single number. The closest number it has is 30 on the sheet up the page, and that number is 2.042. There's S, and there's square root of n, okay? And then there it is. So this says the average student is spending between $3.71 and $5.29 is what that's saying, okay? Let me go to the calculator, and I'm going to show you how to calculate this number off the calculator. All right, so on the calculator, you're going to go stat and go to tests, okay? And we're going to go to T interval, and it's a ways down. There it is right there, T interval. and you're going to type in what X bar is. And X bar is $4.50. Then you're going to type in the standard deviation, which was $2.25. And then you're going to type in the number of samples that we had, which was 34. And the confidence level we chose was 95% confident. Once you get that all typed in, you can just hit calculate, and it'll do all that work for you. And if you recall, that's in money, $3.71 and $5.29 will be the answer to that, okay? That's probably the easier way to do it. You won't be as likely to make mistakes. Okay. Now, the last two questions. This is interpret the meaning of the confidence level, not the meaning of the interval, which I did in the previous problem, but the meaning of the confidence level. Another sentence frame you should memorize. Now, the theory behind the meaning of the level is, if we sampled 34 kids again out of ASB, we're very unlikely to get the exact same mean and the exact same answer. But we're fairly likely, in fact, we're 95% likely, to capture the true mean if we found out what that was later. So, what happens is, you can do an indefinite number of studies and produce intervals. And about 95% of them will actually capture the truth if you found out what that was later. So the interval is 95% accurate, the concept of it. So this is my sentence frame for the meaning of the level, not the interval. If the process was repeated many times in the same manner, approximately 95% of the confidence intervals produced would capture the true mean. That's the meaning of the level, okay? Now, the other one is how many samples do you need? Here we go again, okay? So for the samples that we need, I told you earlier that we used T star here for developing the confidence interval for a mean. However, if you want to know how many samples do you need, then you can't use T star because T star relies on already knowing how many samples you have. So you have to go to something generic, and that generic number is Z star at the bottom of the critical value page, okay? And that is 1.96. Then we're going to assume that our standard deviation S is the same as sigma. It's the same idea. $2.25. And we don't know the samples that we need, so it's square root of n. So this is our equation. And we want it within 50 cents. And there you go again. You're going to have to solve this small equation, and you'll get a decimal, but round to the nearest whole number because it's a sample. We can't have a partial sample. You got to have a whole number sample. Okay? So that is that for the mean. So what we did here in chapter 8 was the confidence intervals for a mean and a proportion. Good luck to you.